Learning the multiplication tables is an essential part of our elementary education. Multiplication and the times tables are building blocks for other math topics taught in school and beyond. In this video, our focus of attention will be the number 9. Let's start with the times tables for 9. One way forward is to memorize them, which is what a majority of learners do. Another solution is to do them on your fingers. Why need to memorize when you can use your fingers instead? This is a pretty cool trick, and I have put up some material on this topic. Please check it out if you want to know more. But there is an even easier way to write the 9 times tables without memorization and without using your fingers. First, write down the numbers from 0 to 9, starting from 0 and moving all the way to 9. Now repeat these steps, but this time start from the bottom and move upwards, like this. That was not too bad, and there you have it, the 9 times tables. This is a nifty little trick, especially when you are not sure of a result. It's easy to replicate, and learners love the aha moment at the end. Let's now look more closely at these results and see if we can spot a pattern. Let's start with the first result. 9 times 1 is 9. Please note that our multiplicand is the 9's number. We will keep the 9's number as the multiplicand in all our examples. Now, what if we broke this result, which is 0, 9, into two parts, 0 and 9. 0 is 1 less than 1, the multiplier, and 9 is the value of subtracting this result from 9, our multiplicand. Let's see if this pattern applies to the next result, which is 9 times 2 is 18. Again, we break 18 into two parts, 1 and 8. 1 is 1 less than 2, the multiplier, and 8 is the result of subtracting 1 from 9, our multiplicand. Why don't you pause the video and see if this pattern applies to a few of the remaining 9 times table results. The pattern fits, doesn't it? So let's write down the pattern we have just seen. The first part of our result is 1 less than the multiplier. The second part is the difference of the multiplicand and the above result. But does this pattern work for bigger numbers? Will it, for example, work in this case? Calculating the result using the conventional method taught in schools is going to be time consuming. So let's see how our method fares. For the first part of the result, we reduce the multiplier by 1. The result is 24 minus 1, which is 23. The second part is the difference of the multiplicand and the above result. So we subtract 23 from 99. That gives us 76. And putting these two results together, the answer is 2376. Let's pull up a calculator and validate our result. This is the correct answer. With this newly gained confidence, let's tackle a much bigger problem. What is 9,999,999 times 8,656,230? So as before for the first part of the result, we reduce the multiplier by 1. This gives us 8,656,229. The second part is the difference of the multiplicand and the above result. We thus subtract 8,656,229 from 9,999,999. Let's do this together, shall we? 9 minus 8 is 1. 9 minus 6 is 3, 9 minus 5 is 4, 9 minus 6 is 3, 9 minus 2 is 7, 9 minus 2 is 7 again, and 9 minus 9 is 0. The second part of the answer is 1,343,770. And combining the two together, we get this mammoth answer: 86,562,291,343,770. Now let's validate our result. I'm not sure if a standard calculator will give us such a large answer. Let's check it out. Great, that worked. When I first saw a friend doing a similar problem mentally, I had an experience similar to one when watching a magician perform her final act. It was confounding, but no longer so. Now many of you would have noticed that both the multiplicand and the multiplier have the same number of digits. For example, look at this problem we tackled earlier. 99 times 24. Both 99 and 24 have the same number of digits, which is 2. Let's now try a problem where the number of digits is unequal. Does the pattern work? So here is our next problem. What is 999 times 53? In this case, the multiplicand has more digits than the multiplier. Please keep this at the back of your mind. Now let's apply our pattern to this problem. For the first part of the result, we reduce the multiplier by 1. The result is 53 minus 1, which is 52. The second part is the difference of the multiplicand and the above result. 999 minus 52 is 947. And putting these two results together, we get our final answer, which is 52,947. Let's check our result. Yes, it is the correct answer. Let's now look at a third scenario. Does our method apply to this exercise where the number of 9s is fewer? 99 times 768. As before, let's apply our pattern to this problem. We reduce the multiplier by 1. 768 minus 1 is 767. We then find the difference of the multiplicand and the above result. 99 minus 767 gives us a negative result, which is minus 668. This does not look right. As you can see, this method does not work when the number of 9s in the multiplicand is less than the number of digits in the multiplier. So to summarize, in this video we saw a special case of multiplication. Multiplication with 9s. This method works when both numbers have the same number of digits or the all 9s number has more digits. I hope you found this technique useful. In the next video we will look at another specialized multiplication concept, so do stay tuned. Thank you.